I'd like to start today with the warm-up. I'd like you to use right triangle trig to solve for the missing variables using SOHCAHTOA. When you're ready to see the answers, press play, but pause until then. Okay, here are the answers. In the first one, you should have used tangent of 62 is equal to x over 7. And then you should have multiplied both sides by 7 and gotten 7 times tangent of 62. Oops. And when you plug that into your calculator, making sure that it is in degree mode, you get 13.2. In the middle one, you can see that you have the 18-degree angle. So to find this side here, I have to say tangent of 18 is equal to the opposite over the adjacent, multiply both sides by x. So now I have x times tangent of 18 equals 4. And when I divide both sides by tangent of 18, I get approximately 12.3. Then, in my last problem, I'm solving for the angle. I notice that I have the adjacent side and the hypotenuse. So I use cosine of x equals adjacent over hypotenuse, 6 over 8, and inverse cosine of 6 over 8 gives me an angle of 41.4 degrees. Today we're going to talk about word problems involving right triangles. Do you remember what the angle of elevation and depression are? I'm going to remind you. So, if I am in the ship, or boat in this case, I measure the angle of elevation from my line of sight up to this hypotenuse here. This is the angle of elevation. Make that smaller. Okay. If, on the other hand, I'm in the lighthouse and I would like to see what my angle of depression is, I would measure from my horizontal line of sight down. This is the angle of depression. You'll notice that the lines of sight are parallel, so the angle of elevation is congruent to the angle of depression. And this just shows the angle of depression here, and that they're both congruent. Angle of elevation is equal to the angle of depression. So let's take a look at our first word problem. A surveyor can measure the width of a river by setting up a transit point. At this spot, I always stop and sketch. So I have a river, and they are setting up a transit at a point on one side of the river. So right over there, they're setting up that transit. After turning through an angle of 90 degrees, the surveyor walks a distance of 200 meters to a third point, B. And using the transit at point B, the angle is measured to be 20 degrees. So now I have this nice right triangle here, and this is 20 degrees. So I'd like to find the width of the river. Now I'm going to remember that 200 is in meters, because when I'm done, whatever value I get for x is also in meters. So now I'm looking for the opposite side, and I'm going to divide by the adjacent side, so that's tangent. Tangent of 20 is equal to x over 200. So to solve for x, I multiply both sides by 200. And now I have to plug that into my calculator. And when I do that, and again, my calculator is in degree mode, I find that x is equal to 72.8 meters. Although that said rounded to the nearest meter. So my answer would be 73 meters. Okay. In this next problem, it says a meteorologist finds the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. On December 1st, 2006, at Midway Airport, a ceilometer was employed to find the height of the cloud cover. It was set up with its light detector 300 feet from its light projector. If the angle of elevation from the light detector to the base of the cloud is 75 degrees, what is the height of the cloud cover? I'd like to give you a chance to try this. Try drawing a sketch and see if you can't find the answer. Press pause on the video, and when you're ready for the answer, press play. Okay, we're back. So the ceilometer is right there, and the height of the cloud is what I want to know, x. Now, the detector is placed at a separate point 300 feet away from the ceilometer, and the angle of elevation, which remember is measured from the horizontal up, is 75 degrees. So tangent of 75 is equal to the opposite over the adjacent side, x over 300. To solve for x, I multiply both sides by 300, and I find that x equals 300 times tangent of 75. And when I plug that into my calculator, I get 1,119.6 feet. I know that it's in feet because my ceilometer was measured in feet. The distance between the ceilometer and the detector is 300 feet. I would like for you to try this problem. Press pause on the video, and when you're ready for the answer, press play again. Okay, I have a flagpole. It stands 40 feet high. Its shadow is 20 feet long. The shadow's on the ground. The flagpole is vertical. And it says the angle of elevation to the sun is what I'm looking for. So the angle measured from the horizontal up. This is the opposite side of that angle. This is the adjacent side of that angle. So I use tangent. Tangent of theta is equal to 40 over 2. So tangent, I used inverse tangent of 40 over 20, which is 2. And when I plug that into calculator, I find that is 63.4 degrees. Okay, here's another problem I'd like you to try. When you're ready for the answer, press play again. Okay, I have drawn a crude picture of my skydiver. He is at a height of 600 feet here, and he sees the landing circle at an angle of depression measured from his line of sight, the horizontal down 60 degrees. And it says, how far is he from the landing circle? Now, it doesn't say how far horizontally is he from the landing circle. How far is he from the landing circle? That is a direct distance. If we were looking for the horizontal distance, it would have said so. So what I used was special right triangles, and I found that my hypotenuse was 400 square root of 3. When I plugged that into my calculator, I got 692.8 feet because 600 is in feet. Okay, give this a try, and I would like to add one thing to it. I'd like to tell you that this is the horizontal distance. Okay, when you are ready for the answer, press play on your video. Okay, I have a plane. It's 12.5 miles away. It's heading for an airport, and it should say 12.5 horizontal miles away. It's flying at an altitude of 5 meters. I hope it's more than 5 meters, 5 miles. So this altitude, this height, is 5 miles. And I want to know the angle of depression. Notice I measure the angle of depression from the horizontal down, but my angle of depression is congruent to the angle of elevation. So now I can set up tangent. This is my opposite side. This is my adjacent side. Tangent of theta is 5 over 12.5. I solve for my angle by taking inverse tangent of 5 over 12.5 and plugging that into my calculator. I find, let's see, I have to do it. Second tangent of 5 divided by 12.5 is 21.8 approximately. So 21.8 degrees. That concludes the examples that I wanted to do today. Check online for your homework and start that now. Have a great weekend.